Okay, so what we're going to do before we get started with chapter 6 is quickly go through one-to-one functions and inverses, because it's going to help us set these things up with their trig functions. So I'm going to go brief but as thorough as we can here. If you need to look through it some more, it's in 4.2. Okay, so one-to-one functions must pass the horizontal line test, right? Functions pass vertical line test, so the one-to-one function passes the horizontal. Okay, inverse. Let's say I give you this f of x equals 2x plus 3. Obviously, that's a line. We know inverse undoes whatever the original function does here. So we'll find the inverse, like you guys did in college algebra. So we'll switch the x and the y. We'll solve for this new y. And then we'll write it with that inverse notation. So if the original function here multiplied by 2 and added 3, well, then our inverse has to subtract 3 and divide by 2. So a way to think about it is the inverse always undoes what the original does. Okay, if the inverse squares, or if the original squares something, the inverse square roots it. All right. You can look on 261 here if you want another little example of this. What we want to do is quickly go through composing these two guys together again. So here's our original, and there's our inverse, and we want to show what happens when we compose them. I'm just going to do one way, because if you'll remember, when you do it both ways, you get the same thing. So I'm going to do f of inverse of x. So I'm going to plug the inverse into the original. So you always start on the inside. So there's my inverse, x minus 3 divided by 2. Now I want to take that and plug that into my original. So my original says 2 times some blob, and then I want to add 3. Well, what's going in my blob is this guy right here. If you need more practice with compositions, check out Brightstorm, where they do a couple simple examples if it's been a while for you guys. So 2, we plug this guy in here, plus 3. Those 2's will cancel. X plus 3, or x minus 3 plus 3 just comes out as an x. So if you take the inverse into the original, you'll get an x. If you do the original into the inverse, you'll get an x. If we look at here, I found a couple pictures of inverses for you. So inverses switch the x and the y. As you'll remember, there's a picture on 263. Okay, I Google imaged a couple here. The red one is your original parabola. So the inverse is the sideways parabola guy. Okay, this guy here, so here's a red one. I have no idea what the equation is for it. Let's call the red the original. So then the blue here is the reflection. And the idea is inverses are always reflected over the line y equals x. Okay, they're perfectly symmetric to that line. So if you take this point here, symmetric to this guy down there. Why we want to do this is a quick little discussion of domain and range here. So when you do an inverse, your domain and range switch. So what was your domain becomes your range. What was your range becomes your domain. And that's what we're going to use with these trig functions. There's 4 properties to kind of start chapter 6 here. If you don't have your book, you can take a look at them before class tomorrow or during class. Just kind of like what we just talked about here, if you want to have those down to keep stuff in track. Okay, now we can actually get into what we're doing. So this is starting 6.1 here, okay, and we're doing inverses of our 3 major functions: sines, cosines, and tangents. So you don't need to copy these pictures down necessarily, but I wanted to show them to you to see where we get this stuff from. We're not just pulling it out of some math magic hat. Okay, clearly the line in blue is a sine graph. So we drew a couple different periods there with it. Okay, I know the scale on the bottom's a little different than we're used to, but that's fine. Everything still works. Domain for your sine clearly is all x values. Range, -1 to 1. Okay, it's never dropping below -1. It's never going above +1. Okay, but the problem is the sine is not a 1-to-1 function because this horizontal line right here clearly hits a couple places. So what we have to do is restrict it. So we can make the sine a 1-to-1 function if we come in and we chop it up here and here to give us this picture right here. So if we only go from -π/2 to +π/2, this will pass horizontal line test, passes vertical line test, so it's a 1-to-1 function. Okay, so we're only looking at sines from there to there. All of this here will be given to you tomorrow on a little sheet with the cosine and tangent ones as well. So here's just kind of some definitions. If we say y equals sine to the -1, that's our inverse function, okay? So that means x equals sine of y, because we're going to switch the x and the y's in solve form. We just talked about where this graph takes place from -π/2 to π/2, okay? And from -1 to 1. Now, domain and range have switched here. So this is now for the inverse. So this used to be x's for our domain, and this used to be y's for our range. They've now switched because we're looking at inverses. So here in the red is our original. Here in the blue is our inverse. So x and y switch. So it now goes from -1 to +1 on the x and -π/2 to π/2 on the y. Okay, if you take the inverse of the original, you get the original, but the trick is it can only be in this range right here. And we'll talk about how we want to keep that straight. If you take the original of the inverse, it comes out to the original, and it's only going to be between -1 and 1. The difference between these is, are you finding an angle or are you finding a value? Okay, so domain of the inverse becomes the old range. Range of the inverse becomes the old domain. And that's what your picture looks like. Okay, let's do a cosine. Well, first, here's the distinction between them before we do cosine. So if I tell you to do sine of π/3, we just spent all last chapter doing that. I want a value. Okay, so sine of 60 degrees equals square root of 3/2. That's a value. If I say sine -1 of 1/2, 1/2 is a value. So I'm asking you to find an angle. So the question is, where is the sine 1/2? Okay, and that's the biggest distinction. So whatever you're given, find the opposite. Here's an example of a type of problem, and I'll just let you guys look at this here. Find the exact value of inverse sine of square root of 3/2. We want to go backwards. We want to find an angle. So pause it if you need to jot that down and see how I came up with square root of 3. And then also ask yourself what would happen if I made this negative square root of 3 right there.